Okay, who gets a packet here? Okay, we start something totally different now.
Is it any camera thing?
No, we'll do that extended. So you guys better start talking or responding. Okay, that'd be hilarious. Go ahead. Something's wrong with the seating arrangement. Everybody back up 1 foot. Okay, so the next 2 chapters we study, they're going to be related. It's like the last 2, right? Permutations, combinations, and then probability. You can't do one without the other. And then before that, we had vectors and parametric equations. They went together. So the same thing here. So we're going to do sequences and then series. So what the heck is a sequence? So today is the review. This is what you should have learned last year. I'm not sure if you actually learned it or not, but you should have. Okay. A sequence is a function whose domain is the positive integers. Now, normally functions are written like this, but sequences are written like that. See, like this. You guys are used to functions, right? But usually the domain of functions is going to be all real numbers. But for sequences, the domain is just the positive integers. So it would look like that. So if somebody were to ask you, okay, write the first 5 terms of this sequence. In fact, the first problem on tonight's homework, you have to write the first 5 terms. What do you think? What are the first 5 terms? Just plug in 1, 2, 3, 4, 5, because the domain is the positive integers, right? Plug in 1. Plug in 2, 3, 4, 5. This is a sequence. Can you see now why the domain is the positive integers? You start by plugging in 1 because that's the first term. And then the second term, the third term, the fourth term, the fifth term. There's no such thing as the 1.5 term, right? Or the -4th term. Right? You start with the first term. That's why the domain is the positive integers. You plug in 1, 2, 3, 4, 5. You get it? Woo! Okay, so the first sequence that we learned in Algebra 2 was the arithmetic sequence. Now, it looks like arithmetic, but it's pronounced arithmetic. An arithmetic sequence has a common difference. It means you keep adding the same number all the time. So, something like this. 3, 7, 11, 15, 19, ... This is an arithmetic sequence because you keep adding 4 every single time. There's a common difference. Now, what was the formula for an arithmetic sequence that we learned in Algebra 1? A sub n equals A1 plus n minus 1e. Every Algebra 2 book has that formula in it. And pre-calculus. Does that look familiar? Plus on the SAT cheat sheet, you got that formula in there too. So, A1 is the first term. See, this is like A1, A2, A3, A4, A5. So A1 is the first term, which is 3, plus n minus 1. N is the independent variable. And what do you think D is? The common difference, which in this case is 4. But of course, we want to simplify this. So if you distribute times the 4 and simplify, you get 4n minus 1. Now, since we are honors, I would expect you guys to just look at that and write down that formula. If you're in my summer school class, I taught you it, right? Look, if the common difference is 4, then you just write 4n, because look, the common difference gets multiplied by n, right? So if the common difference is 4, you just write down 4n, and then you adjust it. If I plug in 1, you should get the first term, which is 3, right? So if I plug in 1 here, 4 times 1 is 4. What do I have to do to 4 to get 3? You minus 1. You just adjust it. Okay, let's do another one. What about 1, 4, 7, 10, 13, ... Is this an arithmetic sequence? Yes, because it has a common difference, which is 3. So, I mean, if you want to, you could just use the formula. Okay, that's fine. But come on, we're honors. So if the common difference is 3, you write 3n. And then if I plug in 1, you want to get the first term of 1. So 3 times 1 is 3. What do I have to do to 3 to get 1? You subtract 2. Isn't that a lot easier?
Can you just do A1 minus the D?
What?
Can you just do A1 minus D?
A1 minus D.
Yeah, like 3 minus 4, negative 1 minus 3, negative 2.
What you talking about?
Can you just take the first term and subtract the common difference?
Take the first term. Yeah, isn't that the same thing? Because look, when you distribute this 4,
Yeah.
right? That's the same thing.
I know, that's easy to calculate.
What you talking about? It's easy. Gorilla could do that. Okay, we're moving on. What about geometric? What the heck is a geometric sequence? It's a sequence that has a common ratio. That means you keep multiplying by the same number every time. Like this. 3, 6, 12, 24, 48, dot, dot, dot. What's the common ratio? 2. You keep multiplying by 2 every time. So if you keep multiplying by the same number every time, we say that this is a geometric sequence. And the formula, what's the formula we learned in Algebra 2? an equal a1 r to the n minus 1. These should all look familiar to you, right? So in this case, it would be a1 is the first term, 3. The common ratio was what? 2 to the n minus 1. That's it. It's that simple. So if you plug in 1, you get the first term, right? You plug in 2, you get this. You plug in 3, that. So if I ask you for the 100th term, you just plug in 100. We call these explicit formulas. Because if you want to find the 5th term, you just plug in 5. If you want to find the 10th term, you plug in 10. But explicit formulas are not the only formulas to represent sequences. Tomorrow we're going to learn another way. Recursive. You guys did that last year? Recursive? What's that? Okay, so arithmetic, geometric, easy, right? I'll give you a hint, okay. You know when you do the harder problems, like you look at the last problem on tonight's homework, that's the one that separates the sheets from the goat. You have to know how to label sequences. Because I'm not going to just give you something like this and ask you, okay, what is the 5th term? Come on. Or write the formula. That's algebra 2. We kick it up a notch. So if you have an arithmetic sequence, this is how you label it. You call the first term A. Like, let's suppose we don't know any of the terms. How do I label the second term if it's arithmetic? A plus D. This is not A1, it's A comma. What's the third term? A plus 2D, A plus 3D, dot, dot, dot. Right? Because you keep adding D every time. This is if you don't know any of what the terms are. What about geometric? How would you label a geometric sequence? If you call the first term A, then AR squared, AR cubed, dot, dot, dot. So you keep multiplying by R every time. So if you have a sequence that's unknown and you have to piece it together, this is how you start. So this is what you're going to have to do when you do the last problem with tonight's homework. So if a sequence is arithmetic or geometric, we have formulas for them. So it's quite easy, right? But what happens if a sequence is not arithmetic or geometric? What do? And there's no formula for it. What do? You have to use your your mathematical prowess. All the experience that you had in mathematics all through the years. From coming out of the womb, where some of you, while you're in the womb until now. You have to use all that experience. Okay, so I'm going to give you a sequence. You tell me what the explicit formula is. Now, the first few will be pretty easy. Okay, what would be the explicit formula for this sequence? See, like, these are numbers I know, Mr. Park. We don't know these numbers? I wrote it down like 5 minutes ago. 1 squared, 2 squared, 3 squared, 4. 5 squared, 6 squared, 7 squared, more. These are the square numbers. So what's the formula for this? N squared. Oh, you guys think you're good now? Okay. You guys think you're good? These are the cube numbers, right? 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, so forth. So what's the explicit formula? N cubed. Oh, you guys think you're good now, yeah? Okay, what about this? Now, if I were to ask you, see, this is the difference between elementary school and pre-calculus. In elementary school, they would give you these numbers and they would ask you, what is the next number in the sequence? Mocha?
Is that a BN?
Yeah. A sub n, B sub n.
You can use anything.
Just like functions, right? F of x, g of x,
Oh.
h of x, right? So A, B, C, yeah, whatever. Doesn't have to be A, just like functions doesn't have to be F, right? Anyway, what is the next number in the sequence? This is elementary school. What's the pattern here? Multiply by 1 to get from there to there. You multiply by 2, you multiply by 3, you multiply by 4. You see a pattern, or these are just random numbers. You multiply by 5, you multiply by 6. So the next one you can multiply by 7, which is 5040. Okay, that's elementary school. What is the explicit formula for this sequence though? In other words, if I want the 12th term, what's a formula I can just plug 12 into? Come on, people! We just finished probability! Yeah, these are the factorial numbers. So what's the formula? So what is it? Okay, look, this is 5 factorial, 4 factorial, 3 factorial, 2 factorial, 1 factorial, 0 factorial. There you go. N minus 1 factorial. Oh boy. We cannot even do the easy ones. We didn't even get to the medium ones yet. Maybe we gotta go back even further. Can you guys even do like this? What about this? I'm just curious. Can you even do like the odd numbers? What is the explicit formula for the odd numbers? It's arithmetic, people. What's the common difference? 2. So you write 2n, and then you adjust. Minus 1. Can you guys do that? Done? Like you're staring again. Some of you not even doing that. Okay, let's kick it. Okay, you guys think you're good? Let's kick it up a notch. Okay, now I'm sure you could tell me what the next number is, right? Like elementary school. What is remember those tests you had to take in elementary school? What is the next number in the sequence? So what's the pattern? Add 4, you add 6, you add 8, you add 10. Is there a pattern to that, or these are just random numbers? There's a pattern! So what's the next one? Add 12, so 42. That's elementary school though. What's the explicit formula? See, the reason why you want the explicit formula is because then I'm going to ask you, what is the 1000th term? Or since this is 2013, what's the 2013th term? You need a formula so you can just plug it in. Unless you can keep on writing until you get to the 2013 term. I don't think so. So what's the formula? Somebody. Somebody besides Chai. Yoshina. Come up with something. Just conjecture something. Sito? Good? Just stop there because everybody. Does somebody want to take a guess? Hanaoka. Somebody come up with something, Saito.
Does that have to be right?
Well, I don't know.
'Cause
It would be nice if it is.
I can't think of anything that's right.
Kwok. 10. Leon. Is this what we're gonna get on when we video on Wednesday? It's okay. Fine.
N factorial
Here.
plus 1. No.
Wait,
it's not.
n what?
No, it's not right.
N factorial.
No, it's not right.
No, let's just try it.
Oh no, it's not even close.
N factorial plus 1. Is that what you said? Okay, this is how you check to see if it's right. If I plug in 1, do you get this? We cannot even plug in 1. If I plug in 1, do you get that?
Yes.
Yes. If I plug in 2, do you get that?
No.
No. Okay, so you're wrong. That's how you tell. Okay, now, if you come across a sequence, it's not arithmetic. So the first thing you gotta ask yourself, is it arithmetic? No, it doesn't have a common difference. Does it have a common ratio?
No.
Some of you going, yeah. To get from there to there, you multiply by 3. So multiply by 3, you get this. No, it's not geometric. If it was arithmetic or geometric, we have a formula. We can just plug it in. But it's not arithmetic or geometric. You gotta rely on your mathematical prowess. So one technique we like to do is break it down. Like 2, that's 1 times 2. 6 is 2 times 3. 12 is 3 times 4. 20 is 4 times 5. 30 is 5 times 6. Do you see a pattern to these numbers, or these are just random numbers? There's a pattern! How do you generate the numbers 1, 2, 3, 4? N. How do you generate the numbers 2, 3, 4, 5? N plus 1. There's your formula. You break it down. Okay, let's try another one. What did I just say? Okay, so what's the explicit formula for this? So, this is what should be going through your brain. Is it arithmetic? Is there a common difference?
No.
Is there a common ratio?
No.
No, okay, you gotta rely on prowess. Does it look familiar, like square numbers, cube numbers, factorials?
No.
No. Okay, so?
Break it down.
Break it down, okay, somebody. Just try something. Like 6, the first thing you think of is 2 times 3, right? Isn't that the first thing you think of?
Yeah.
Okay, but what's 24? 4 times 6? 3 times 8?
4 times 6. 2 times 12.
Okay, but you want it so that there's a pattern. 4 times 6. 6 times 10. 6 times 20, but then see, there's no pattern, right? So maybe you gotta think
2
of,
times 8.
how about 1 times 2 times 3? 2 times 3 times 4. 3 times 4 times 5. 4 times 5 times 6. Is there a pattern to this, or these are just random numbers? There's a pattern. Look, how do you generate 1, 2, 3? N. How do you generate 2, 3, 4? N plus 1. And how do you generate 3, 4, 5? N plus 2. Pakui. These are not even the hard ones, people. Okay, what about this? You guys think you're good, yeah? 1, 3, 6, 10, 15, dot, dot, dot. Hey, we did this in class, Mr. Park. These are the triangular numbers again. And you taught us the formula in the second quarter. Or was it the first quarter? I told you what the formula was. Okay, if you cannot remember the formula, then you better break it down. Because that's not arithmetic or geometric. You gotta break it down, people. Anybody? 1 times 1. No. 1 times 2 over 2. 2 times 3 over 2. 3 times 4 over 2. 4 times 5 over 2. Do you see a pattern? Or these are just random numbers? See, when you break it down, you got to be able to see a pattern. So how do you generate the numbers 1, 2, 3? How do you generate the numbers 2, 3, 4? N plus 1 over 2. There you go. That's the formula for the triangular numbers. I told you that when we studied that. Okay, believe me, starting from today, triangular numbers are going to come up quite often. It pays to remember this formula. If not, good luck. That's all that. Are we ready for the harder problems yet? At least say no. Okay, what about this? We're going to just go to this already. 1, negative 1. 1, negative 1. 1, negative 1. Now I know for a fact this was done in Algebra 2. Because in Algebra 2B, that's what we're learning right now. This is 2B. Not 2 honors, 2B. How do you generate, we call this an alternating sequence because it goes positive, negative, positive, negative. Come on, last year. Can I remember what you did last year? Okay, I'll just tell you already. Negative 1 to the n plus 1. Because look, you plug in 1, you get negative 1 to the second, which is 1. You plug in 2, you get negative 1 cubed, which is negative 1. Negative 1 to the, if you plug in 3, you get to the 4th. Can you see how it works? In fact, is this the only formula you have for it? No, you can put negative 1 to the n plus any odd number you want, right? What, with n minus 1, would that work too? You couldn't even tell me yes or no. If I plug in 1, do you get this? If I plug in 2, do you get that? If I plug in 3, do you get that? Yes! N plus any odd number works. So what if I did n plus 2013? Would that work? Yes! However, it's standard mathematics, you just go n plus 1. What if it started with negative 1? Like this, what if it went this way? Negative 1, 1, negative 1, 1, negative 1, 1. What if it started negative? This one started positive. And what would the formula be? Negative 1 to the n. Or n plus any even number. Right? Because negative 1 to the 1 is negative 1. Oh my goodness, we have ah! Okay, you guys think you're good? 1, negative 1, 1, negative 1. Okay, the same sequence. This is the kind of problems you can see on the test. Okay? I'm going to give you a formula like this. Cosine. Box. Fill in the box. What explicit formula will give you these numbers here? Fill in the box. Okay, let's review how cosine works. Okay, we want 1, negative 1, 1, negative 1. Think of the unit circle. Where on the unit circle is cosine equal to 1? Right there, right? At 0. Where is cosine equal to negative 1? At pi. Then when is cosine 1 again? 2 pi. So what you gotta do is you gotta think, oh, that's cosine 0, cosine pi, cosine 2 pi, cosine 3 pi, dot, dot, dot. Is there a pattern to this? Or these are just random? Maybe if you put the pi there, maybe that'll make it easier. 0 pi, 1 pi, 2 pi, 3 pi. Is there a pattern? You bet your pimpy there's a pattern. So basically, all you have to do is generate the numbers 0, 1, 2, 3. How do you generate the numbers 0, 1, 2, 3? N minus 1. There you go. It's like you never saw this before. Okay, fill in this box. Sine box. To generate these numbers. Okay, think of the unit circle again. Where is sine equal to 1? Pi over 2. When is it negative 1? 3 pi over 2. And then when is it 1 again? 5 pi over 2. And 7 pi over 2, right? So what you want to do is you want sine of pi over 2, 1 pi over 2. Sine of 3 pi over 2 is negative 1. Sine of 5 pi over 2 is 1. Sine of 7 pi over 2 is negative 1. Is there a pattern to this? Or these are just random things? There's a pattern. Look, the only things that are changing. 1, 3, 5, 7. How do you generate the numbers 1, 3, 5, 7, which are the odd numbers? We just did it 5 minutes ago. 2n minus 1, that's the odd numbers, and then pi over 2. Oh my lord. Okay, finally, what about tangent? Tangent box. Fill in the box to generate these numbers here. This is supposed to be an easy chapter, but it might not be. Just like last one's supposed to be, but this wasn't that. Okay, where is tangent 1? Where on the unit circle is tangent 1? Right there, pi over 4. Where is it negative 1? 3 pi over 4. Then 1, then negative 1, and it just keeps on going around, right? So what we want is, we want tangent of 1 pi over 4, that's 1. Tangent of 3 pi over 4 is negative 1. Tangent of 5 pi over 4 is 1. Tangent of 7 pi over 4 is negative 1. So is there a pattern to this? 1, 3, 5, 7? Again, when it's the odd numbers, Mr. Park. 2n minus 1, and then pi over 4. Boy! Okay, so the lesson here is, if it's not arithmetic or geometric, you got to use your mathematical prowess. Right now, on the mathematical prowess meter, here's period 3. Period 3, the mathematical prowess meter. This is where you guys are. By the time we take the test, you guys better be up here somewhere. Basically, we're looking for patterns. We're describing patterns. That's what you do when you have a sequence, right? You have a sequence and you describe it. Oh boy. Okay, what time is it? Okay, so like I said, tonight's homework is just review, yeah? Supposedly review. Okay, let me pass out the test. Everybody here took the test?